All right, you guys, our final section of notes of the year is 2.4, and it's on the chain rule, which is just one more great tool to help you find the derivative of a function very easily. This is another longer section. You will notice I'm trying to keep this super short, just show you the very basics of the chain rule with a few simple examples so that you have enough to go ahead and do those problems on Delta Math just to test out your ability to apply this chain rule. So here is what the chain rule is. The chain rule is appropriately named because it kind of links together these different derivatives as you go. So the chain rule is used when you have a function within a function. So let me get my little blue lightsaber. Here we have f of g of x. So this is a composite function, which is a function inside of a function. And the derivative of that is simply the derivative of the outside function, and you leave g of x alone, times the derivative of the inside function. So I'm going to just jump into the examples. I feel like this doesn't actually start to make sense until you see it in motion. So actually, I'm going to do one little example out here. So in your notes on 2.4, if you've got a little extra space over here to the right, I'm going to do a quick little guy here. All right, so let's say we have the function 3x plus 1 raised to the fifth. And this is similar to number 1, but I wanted to start off. So the outside function, so we have this inside function, 3x plus 1. The outside function is something raised to the fifth power. So you can think of this whole inside function in terms of taking the derivative. Let's think about if we had a function that was just x raised to the fifth. Well, then to find the derivative of that, it would just become 5x to the fourth. So this entire thing right here, think of it as a giant x in the beginning, and then you'll take the derivative of whatever that inside function x is. So when we go down here and apply this, so the first thing we're going to do is, well, sorry, I'm jumping around so much. I'm going back here. I'm going to finish this because I didn't finish it. So when we're thinking about the derivative of this, f prime, we're going to start by applying the power rule to the outside. So we bring the 5 down. We don't even mess with the inside function yet. It stays exactly how it is. And that's, I'm going to show you where that is here. F prime of the inside function. So f prime is, I just take the outside function derivative, 5x, and then raise that to the fourth power. And I would like to move my red text around, but it's not going to let, oh, there we go. No, not that. Oh my goodness. Okay, sorry guys, technical difficulties, but I can't move anything around for some reason, so I'm just moving down so I have more space. So we bring the 5 down, we leave the inside function alone, and then just apply the power rule. Then I multiply that by the derivative of the inside function. And the derivative of this inside function is just 3. So then I would multiply that by 3, and then you simplify by multiplying the 5 and 3 together, and it would be 15 times 3x plus 1 to the fourth. I don't know what it is about chain rule, but it's just kind of like, I don't know. I like using it. All right, so let's apply this to number 1. Again, it's very similar. I've got the function is an inside function 2x plus 3 being raised to the fourth power. So the derivative of this by, applying the chain rule, we first take the derivative of the outside function, which is anything being raised to a power. Remember, I leave the inside function alone on the first step, and I just differentiate the outside. So that would be 4 times 2x plus 3 raised to the third power. Then I differentiate the inside function, 2x plus 3, which is just 2. Then I multiply or simplify. 8 times 2x plus 3 cubed. And that's it. Okay, let's do another one. Number 2, we've got 4 times x squared minus 5 cubed. this 4 is not a function of x. It's just a coefficient. There's no x attached to it, so it's just going to be along for the ride. So when I differentiate the outside function, which is something being cubed, I bring the 3 down, multiply it by the 4, that's a y, and that would be 12. X squared minus 5, I leave the inside function alone, differentiate the outside. Then I differentiate the inside and multiply that. So that would just be 2x. So my final step here would be simplifying, and I can multiply that 12 and 2x with each other. So the derivative in that simplified form would be 24x times x squared minus 5 squared. And you don't ever need to multiply something like this out. You can just leave it as the quantity squared. All right, cool. Let's look at another one. Number 3. So now we're looking at what appears to be something we would apply the quotient rule to. But considering there is no x value in the numerator right here, I'm trying to figure out my favorite lightsaber. I think it's red. Okay. There's no x up here, which means yes, we could apply quotient rule. Or we could just cleverly rewrite this, because if something is in a fraction, I'm going to probably, let me put this over here. Remember how we know if 1 over x, I could rewrite that as x to the power of -1. I can also just rewrite any quantity in the denominator of a fraction to the negative power. So we could actually think of this problem as 3x plus 5 raised to the -1. And now we can apply chain rule. So we couldn't have applied chain rule in the last video when we used quotient rule, but now that we have chain rule, it's kind of a tool that helps us avoid the quotient rule sometimes. So let's find the derivative. Y prime, again, I'm applying the outside function's power rule first. So I'm going to take the -1, bring it down. I leave the inside alone. Take that to 1 less power, so -2. And then I multiply that by the derivative of the inside, which is just 3. Now when I simplify this, I have a couple things to remember. First of all, this whole thing is being raised to the -2. So that is all going to be in the denominator of a fraction. However, this negative and the 3 will remain in the numerator. So the final answer here would be y prime equals -3 divided by 3x plus 5 quantity squared. You would have gotten the same exact thing had you applied quotient rule. It's just nice that you have options sometimes now. Okay, let's look at another one with roots. So just like when we were applying power rule, the first step was always rewrite any roots as a power, and the same thing applies here. That would be the first thing we would do anyways. So this we would rewrite as x squared minus 3 raised to the 1/2. And now we're just looking at two functions. We've got the inside function and then we have the outside function, and we'll apply that chain rule. So the derivative of y, first we apply derivative to the outside function, so that 1/2 comes down. X squared minus 3, remember that inside function stays the same. And then that would be to the -1/2 when I subtract 1. And then I'm multiplying that whole thing by the derivative of the inside function, which is just going to be 2x. So we do need to simplify this. Let's think of it one term at a time. So I have 1/2, that's a coefficient. And then I have times 2x. So this 1/2 and that 2x are actually going to cancel out, and I'm just going to be left with x in the numerator of a function. My stylus just broke. Great. Give me 1 second. Okay, everything's good. I fixed my little pen. Okay, so where was I? So oh my gosh, okay. We canceled out the 1/2 and the 2, so this x is going to remain in the numerator. We've got x in the numerator, and then this whole thing, because it's being raised to the -1/2, that means it's going to be in the denominator to the +1/2. But remember, the power of 1/2 is the same as square root. So we could write it as the whole quantity to the 1/2, or we can write it as a square root like that. Either way, we're done with that one. Okay, so I'm going to skip these next couple of problems. They follow very similar processes as the four we just did. So I'm going to jump down here, and if you'll notice in number 7, we have it looks similar to the other problems, but if you notice, we've got x cubed times 2x minus 5 to the 4th. So as you can tell by the name of this group of problems, we are looking at a combination of the product rule. So we've got a function of x times a function of x. Here's one function of x. 2x minus 5 to the 4th is another function of x, but this second one is a function within a function. So in the process of applying the product rule, we will apply the chain rule as well. So things get pretty exciting around here. All right, so let's do this. The product rule. So that would be the, either way, there's a couple different ways because order doesn't really matter with product rule. So let's say I take the derivative of the first function, that would be 3x squared, times the second function as is, 2x minus 5 to the 4th. And I add that to the first function as is, so x cubed, times the derivative of the second. And here I'm going to apply the chain rule. So the derivative of the second function, which is just this. So I'm applying chain rule to that. So I'll stick with the color green here. So first I would bring down the 4. Then I would leave the 2x minus 5. That inside function stays the same. Then multiply it by the derivative of 2x minus 5, which is just 2. So I have this whole first term here, and then my second here that I can simplify a little bit. There's nothing much I can do to simplify this too much. So what I would do is just multiply those two together on the right hand side. So y prime, I'll leave this as 3x squared times 2x minus 5 to the 4th plus, and then 2 times 4 times x cubed. So 8x cubed times 2x minus 5 cubed. And that's it. So it helps to stay organized with these because when you start combining things like product, chain, and quotient rule all together in a single problem, it can be a lot to keep track of, but that's why practice helps us. Okay, let's move on to the next. Okay, so these problems are actually problems that I'm going to skip because they turn into pretty complicated processes when you're dealing with powers that are fractions. So we're actually going to skip it because I just want to keep this for you guys. Okay, I do want to do some problems where we are incorporating chain rule with trig. So this number 1 here, we have our outside function, sine of x. Then the inside function is 3x. So again, in applying the chain rule, we take the derivative of the outside function and we leave the inside function alone. So when I take the derivative of sine, which is cosine, I leave 3x in that cosine function. So we leave the inside function alone on our first derivative. Then I multiply that by the derivative of 3x, which is just 3. So this answer simplifies to just 3 cosine of 3x. Let's look at number 2. So here we're looking at the outside function of cosine of x. The inside function is 3x minus 2. So when we take the derivative of cosine is negative sine of x. So in this case, because I have an inside function, I leave it the same. Negative sine of 3x minus 2. And then I'm going to multiply that whole thing by the derivative of 3x minus 2, which is 3. And then we would just rewrite that. So negative 3 sine of 3x minus 2. That's it. Some of you may be wondering, what if you have more than a function within a function, because we could have a function within a function within a function within another function. So, and that's what's so great about the chain rule. You just keep applying it every time. So in this number 3, this third example here, that is an example of a function within a function within a function. So I'm going to rewrite it to help you see why that's 3 separate functions. So this is 1/2, which is not a function of x, it's just a coefficient. So cosine squared of 2x is actually the cosine of 2x and then that whole thing squared. And it's tricky in problems like this because we don't usually think, we just think when it comes to trig functions how we write cosine squared and sine squared, it's harder to realize that that's a function happening as well, something being raised to the second power. So if you think about plugging a value of x in here, first you'd plug it in here, you'd double it. So that's the innermost function. Then you would take the cosine of that, cosine of 2x, and then you would square that. So that's why I rewrote it here so that you could actually see the 3 separate functions. And I like the highlighter tool on here, so I'm gonna use it. So we have the function on x, we have the cosine function is the second function. Oh no, that's not what I wanted. A highlighter. That's the second function. And then the third function happening is this guy. So 3 things. So again, as we start applying the chain rule, we'll see how this unfolds. So y prime, the outside function, the outermost is this whole thing being squared. So I bring down the 2, multiply it by the 1/2. That's convenient because it's just 1. The remaining then it would just be 1 times cosine of 2x. Then I take the exponent of 2, subtract 1, and it would just be to the first power. So this is it in applying the derivative of the outside function. Now I've applied the derivative of the next function, the second outermost function, which would be the cosine function. And the derivative of cosine is negative sine of x, so I'm going to multiply that. This is not subtracting, it's multiplying by negative sine of 2x, because I'm still leaving this inside function alone. Then I take the derivative of 2x, which is 2. So we've taken the derivative kind of 3 times. So then when I simplify this, I can just bring this 2 and this negative out front. So this negative and 2, those are coefficients. So y prime equals negative 2 cosine of 2x times the sine of 2x. So notice those inside functions stay the same until I take the derivative of them. And then this one's fun, number 4, because I'm taking the cosine of sine of x. So here we have 2 functions. The innermost function is sine of x. The outer function is cosine of x. So when we're taking the derivative of this, we take the derivative of the outside function. So derivative of cosine is negative sine, but then I leave the inside function the same. So this is going to feel weird, but we're taking the negative sine of x and then multiply that by the derivative of the inside function, which is sine of x, and the derivative of that is cosine of x. So look what we have. We've got negative sine of x times cosine of x, and there's really no simplifying we can do there. It's not sine squared of x, because I'm not taking sine of x times sine of x. I'm taking the sine of the sine. And I know that can get a little confusing, but I'm going to stop there with trig examples. I just wanted to see a few examples of chain rule with trig. And actually, I think that's enough. I think that's all I wanted to show you guys, and just keep it pretty simple. My goal is just that you are following some of these examples now. So if most of you who probably go to college will likely have to take Calc 1, this will be something that's a little bit familiar to you. So that's it. So you should be ready to finish off that last Delta Math assignment now.